All right, so we've got the 5.5 to 5.6 quiz study guide here. And it asks us here for the sum of the two functions f of x equals 7x squared minus 5x plus 2 and g of x equals 3x squared plus 9x plus 9. When it wants the sum of the functions, it simply wants you to add the two functions together. So f of x is 7x squared minus 5x plus 2. We're going to be adding 3x squared plus 9x minus 9. Officially, we can put parentheses around these. They're not required to be put around those, though, for an addition. If I distribute a plus sign through all the signs to the same, and this is positive. So if it were me just adding the functions, I would just probably write it as an addition statement between the two functions, no parentheses. And then just combine like terms, positive 7 and positive 3x squared add up to make positive 10x squared. Negative 5x and positive 9x, those are different signs, subtract to make 4x, and 9 being bigger makes it positive 4x. And positive 2 and negative 9, also opposite signs, subtract to get 7. 9 is bigger than 2, so it's negative 7. So same signs add, different signs subtract, different signs subtract, bigger positive, bigger negative. So, and there's your answer, that's the sum of the functions. This time it says find f minus g of x, that's find the difference of the two functions. So with subtraction, we do have to worry about using parentheses. So f first, g second, so I'm going to put f of x, which is that, 2x squared minus 5x plus 9. We're going to subtract g of x, which is right here, 3x minus 7. And once again, with the parentheses here, there's nothing in front of it affecting it, so officially everything times positive 1 just keeps it positive 2x squared, negative 5x, and positive 9. The second one, though, has a minus sign in front of it, so that minus is going to distribute. We're going to subtract positive 3x, which is minus 3x. We're going to subtract negative 7, which is plus 7. So again, the minus sign is affecting the signs. 3x changes to negative, negative 7 changes to positive. And once again, it's just like the last problem now, combine like terms. 2x squared is the only x squared object, nothing happens to it. Negative 5x minus 3x makes negative 8x, so adding because the signs are the same, and negative because 5 is bigger. And then positive 9 and positive 7, both positive, we're going to add to make positive 16. Each of these problems here where we're supposed to be adding, subtracting, multiplying, we're going to just leave the answer in simplified form. Don't try and factor anything. Just get what you get and be done with it. For number 3, it says find fg. So fg means f times g of x. So they want us to take f of x, which is 3x minus 2, multiply by g of x, which is 2x plus 3. And all we're looking at here is just a FOIL technique. It's a binomial times a binomial. So first times first gets me 6x squared, both positive makes a positive product. Positive 3x and positive 3, both positive makes a positive 9x. Negative 2 times negative 2x, different signs makes a negative, and that'll be 4x. And last times last, negative 2 times positive 3 makes a negative 6. Once again, different signs, so I subtract. First step with FOILs, get the product, and then after we get the product, we look for like terms. And right here, 9x and 4x are like terms, so we're going to combine those together. 6x squared has no like terms, nothing happens to it. These signs are different, so I subtract to get 5x, and 9 is bigger, so it's positive, and then minus 6 has no like terms. So 6x squared plus 5x minus 6 is the product of the two functions. This is asking me for the quotient f divided by g of x. F of x is this expression. G of x is this expression. F over g means to put that over that. So x squared minus 4x plus 3 over x squared plus 3x plus 2. Now if we look in at this part where it says to reduce to lowest terms, there's an expectation that if we factor these polynomials, there might be a reduction possible. I will say on this particular study guide it doesn't reduce, but on the quiz itself I'll make sure they do reduce. So make sure you're going to go the extra step here. We're going to factor each quadratic trinomial here. Just your basic one with 1x squared, so we're looking for product of net positive 3 that adds to make negative 4. That'd be negative 1 and negative 3. Do the trick to multiply to make positive 3, add to make negative 4. We're going to pair those up with x's because that's the letter. Once again, this is 1x squared, so the same idea here. We're looking for numbers that multiply to make positive 2, that add to make positive 3, and those two numbers are positive 1 and positive 2. Pair those up with x's. And again, nothing matches on top and bottom, so there's no way to reduce it. Expect on the actual quiz that something like maybe this will be x minus 1 also, those would cancel in. But again, since nothing matches, there's no reduction possible. This is actually the best final answer here. Let's just pretend if this said minus like it should have for this problem, then this would be -1 and -2, because -1 times -2 makes positive 2, -1 plus -2 makes -3. And now that x minus 1 matches x minus 1, those cancel, so the end result of this would be x minus 3 over x minus 2. And that's not what the problem states, so again, on this problem specifically, this being a plus sign, that's the right answer, but on the test, expected to break down a little bit more like that. Number 5 says find f of g of 5. So we're looking at a composite function, f of something. The something happens to be a functional value itself. We always start with the innermost grouping there first. So g of 5, if I look at what g of 5 means, it means go up to function g and change x into 5. So here's x, so 2 times x minus 5. Instead of x, we're going to put 5. We're going to work that out. 2 times 5 is 10, and 10 minus 5 is 5. So g of 5 equals 5. We come back over here where this problem is, and it says f of g of 5, but g of 5 happens to equal 5, so we're going to put 5 here. And then f of 5 means to go up to function f and replace x with 5. So this x becomes 5, this x becomes 5. So this is going to be 3 times 5 squared minus 2 times 5 plus 1. Again, this x became 5, this x became 5. This x is being squared, that 5 is being squared, that 5 squared is being multiplied by 3, just as the x squared is being multiplied by 3. Order of operations at this point, 5 squared first makes 25. 2 times 5 is 10. The square happens in this term, the 10. So the fact there's a power here, there's a product here, they're separate terms, you can kind of do those at the same time. If I continue with the product here, 3 times 25 is 75. And finally, 75 minus 10 is 65, plus 1 is 66. And you should expect a numerical answer there. One point of order, the fact that g of 5 equals 5 is coincidental. It does not have to be the same number there. I could have just easily said g of 3. 2 times 3 is 6 minus 5 is 1, so it said f of g of 3. Now all of a sudden g of 3 is equal to 1. Now over here we're doing f of 1, so whatever that equals. So keep in mind that you're going to evaluate this to some number. It doesn't matter what the number is. That number goes in place of g of 5 and then figure out the f part. Number 7 is the same skill as 6, same skill as 5, but this time it's f of g of x, not f of g of a number. So the fact that it says f of g of x and g of x is defined as x minus 5, we just do a quick substitution here, replace g of x with this expression, which is x minus 5. And f of x minus 5 means go up to function f and change the x's, which would be this one and this one, into x minus 5. So I have 2 times x squared minus 3 times x plus 6. Instead of x, we're writing x minus 5, so x minus 5 goes in that parentheses, x minus 5 goes in that parentheses. We have been seeing quite a bit of this picture here this year, this binomial squared picture. Remember that it's simply the first object squared, the second object squared, and then there's this magic middle term, which is just the product of x and negative 5 doubled. So negative 5x doubled is negative 10x. So this right here is the product of that binomial squared there. And then I've got minus 3 times x is minus 3x. I've got minus 3 times minus 5 is plus 15. Be careful, this is a plus sign because two negatives make a positive. This sign is attached to the 3, it's distributing through. We have plus 6. Order of operations told me I had to square that first. Now that I've squared that, now I have to distribute, so now it's multiplication. So now 2 times this, and 2 times this, and 2 times this is positive 2, so the signs are what they should be. So 2 times x squared is positive 2x squared. 2 times negative 10x is negative 20x. 2 times positive 25 is positive 50. And all the rest of the terms are already in simplified form. Minus 3x plus 15 plus 6. So our last step then is after all the simplification is done, now we're looking for like terms. And 2x squared, no other squared terms, nothing happens to that. Negative 20x and negative 3x, those signs match, so I add to get 23x. 20 is bigger than 3, so it's negative. 50 and 15 and 6 are all positive, so I'm going to add them all together. 15 and 6 is 21, plus 50 is 71, and they're all positive, so it's positive. 2x squared minus 23x plus 71 is the end result of f of g of x. Number 7, it asks us for the inverse of the following relation. So that's the first thing we're going to do. We're going to take this relation and make the inverse. And on the study guide, there's 4 ordered pairs on the test. Maybe there's 5 or 6. I don't know. Well, there'll be some number of ordered pairs here. X paired with y. So when I make the inverse of that relation, all I'm going to do, make a new xy chart, and I'm going to interchange the x's and y's. So every y value becomes an x, and every x becomes a y. The pairings are the same, though. So this ordered pair here, I'm going to put x as negative 2 and y as 3. This ordered pair here, I'm going to put x as 3, y as 4. For this ordered pair here, I'm going to put x as 4, y as 5. And for this ordered pair down here, I'm going to put x as 2, y as 7. You take each ordered pair and swap the order to make the inverse. So that's the answer to the first part. So this, I'll highlight it, matches the request that they're asking, which is what is the inverse of that function. The other part of this is asking, is it a function? It means, is the inverse a function? And for functionality, we're looking to see if each x leads to exactly one y. So negative 2 only goes to 3, positive 3 only goes to 4, positive 4 only goes to 5, positive 2 only goes to 7. Each one of these is a different number. They all are paired with a single number only, so that is what a function looks like. So I'm going to say, is it a function? Yes, it's a function. That takes care of the second part of that. Just a quick, if it weren't a function, this is what would happen. So let's just use some pretend here. Suppose there was a fifth term down here that was called 3 comma 4. If it's 3 comma 4, then the fifth term would be 4 comma 3. We'd swap them. And all of a sudden now this is the inverse. And we see that the number 4 is paired with 5. It's also paired with 3. So 4, single number x, is paired with multiple y's. Now all of a sudden it's going to be no. Again, that didn't happen on this problem, but it could very well happen on the quiz. So know how to distinguish a function for the specific problem that's here. That's the answer to the inverse, and it is a yes, it's a function because each x leads to exactly one y. Number 8. Ask for the inverse of f of x equals 3x minus 7. If it's a function, we're supposed to write it in proper functional notation. So, first thing I'm going to do is write it in xy notation. So I'm going to replace f of x with the letter y. It's just easier to work with. So y equals 3x minus 7. We make the inverse by keeping everything exactly the same in the function, but then replacing y with x, x with y. So y becomes x, x becomes y. That's how we make the inverse function. Once we make the inverse function, our next task is to solve for y in our new inverse function. So I want this to say y equals. So I'm going to take this negative 7, make it over here, make a positive 7. So x plus 7 equals 3y. Divide both sides by 3. And I like y on the left-hand side, so y equals that stuff. I can write it as y equals x plus 7 over 3. So that's the inverse relation as is. Now, our other task is to determine if it's a function. If it is a function, we need to write it in function notation. If it's not a function, we'd leave it in relation, just the relation notation. So basically, my question here, this second part, if it is a function, write it in proper function notation. Should it say y equals, or should it say f inverse of x equals? So the question is functionality, and again, the function rule is if I put one thing in for x, I get one thing out for y. That's the rules. So what I'm doing with x to get y is I'm adding 7 and dividing by 3. So I can't pick every number in creation to figure out whether or not every single number works. I just have to convince myself either it is a function, but every input gets one output, or I can find some number out there that would create multiple outputs. So basically the question I'm asking myself is, if I replace x with a number and then add 7 and divide by 3, will I get multiple answers? Like if I put 5 in, will I get 6 and 7 out? Something like that. So obviously adding 7 to a number creates a single answer every time, no matter what the number is. Pick a number, add 7, you get one answer. 5 plus 7 equals 12, and only 12 and nothing else but 12. So kind of that idea. The same thing with division by 3. Dividing by 3 creates a single answer every time, no matter what the number is. So I can see that adding 7 and dividing by 3 creates functionality. So this is a function. And because it is a function, I want to write the answer, instead of y equals everything else, I want to write f negative 1x, read f inverse of x equals my answer of x plus 7 over 3. Okay. Again, if it weren't a function, if it was some answer that created multiple answers for input, so I put one number in for x, I get multiple answers out for y, then I would say it's not a function, at which point I would just circle this answer. So the second part, again, is either this or this. This is if it's not a function, this is if it is a function. So the notation is what I'm looking for to establish whether it's a function or not. So you make the decision, then decide how you want to write the answer. For number 9, this says to find f inverse of x, identify the domain of f inverse of x. And the domain has to do with the fact that f of x equals the square root of x minus 1 doesn't create all the possible things that f inverse is going to create. So we need to restrict a little bit. And the way we do this, first off, is I would look at the f of x function itself. F of x equals the square root of x minus 1. If I look at the domain of this function, recalling the rules for domain at this point in our class, we are not allowed to take the square root of a negative number. We are not allowed to divide by 0. So I see a square root. I know that I cannot take the square root of a negative number, which means x minus 1 has to be greater than or equal to 0. And if x minus 1 is greater than or equal to 0, if I move the 1 over to the other side, that gives me x is greater than or equal to 1. So the domain of f of x is equal to the set of all x values such that x is greater than or equal to 1. And again, all that's telling me is that's the type of values I can pick for x if I were to try and evaluate this to get points out. So put an x in, get a y out, basically. The range, best way to find range is to graph. And once I've established the domain, I'm only going to pick numbers bigger than or equal to 1. And I don't even have to draw it on graph paper. I can just kind of sketch it out a little bit here. Kind of draw it to scale, but it doesn't have to be perfect. Okay, I'm going to pick numbers that look like this. And the very beginning number, the first number in the interval is 1. So I'm going to put 1 in. So 1 minus 1 is 0. The square root of 0 is 0. So I put input x1, output y0. Gets me the ordered pair 1 comma 0. The next number up is 2, because again, greater than or equal to, so I can go bigger. So 2 minus 1 is 1, the square root of 1 is 1. So put 2 in, get 1 out, so 2 comma 1 is an ordered pair. If I put 3 in, 3 minus 1 is 2, the square root of 2 is about 1.4. So 3 goes in, 1.4 comes out, that would be about here. If I put 4 in, 4 minus 1 is 3, the square root of 3 is about 1.7. Put 4 in, 1.7 comes out. And you can do this until you're bored, but you can see that we start at 1, 0, and it starts climbing. Each time I get a bigger number, 1, 1.4, 1.7. The next number up is 2, in case you're interested, and so on. So it's climbing gradually, so I can see that the graph kind of looks like this. And looking at the range is about the y coordinates. 0 is the bottom, then it gets bigger. So the range of f of x is the set of all f of x such that f of x is greater than or equal to 0. Okay. And notice the domain and the range. Domain is all about x. Range is all about f of x, also known as y. All right? So with that in mind, put that on the back burner. That's important, but not really yet. We need to know that to get this part, this identify the domain. But now we want to make the inverse function. So if my original problem says y equals the square root of x minus 1. And again, notice, did this kind of sneakily, but notice that instead of writing f of x equals, I wrote y equals. I just like y better. It's easier to work with. If y equals the square root of x minus 1 and I want to make the inverse function, I'm going to change y to x. I'm going to change x to y. Everything else in the problem stays as is. I want to get that to say y equals. I have a radical square root specifically. I want to get rid of the square root by squaring. So the left-hand side becomes x squared. The right-hand side is y minus 1. And then once I get y minus 1 equals, I'm going to move the 1 over. So plus 1, x squared plus 1 equals y. Right. Now, first off, y equals x squared plus 1, once again, is a function. I can square any number, no matter what number I pick. When I square it, I get a single answer. 1 squared is 1, 0 squared is 0, negative 1 squared is 1, 5 squared is 25, 2 squared is 4. Every single one gets a single answer, and then add 1, get a single answer. So this is a function, so officially I can write f inverse of x equals x squared plus 1. Just like the last problem, I'm expecting you to use proper notation. If it is a function, write it as a function. If it's not, leave it as is. And then if we go back here, the domain part of it, the domain of f inverse of x equals the set of all x such that x does something. Right? So we did all this work here. Again, it's a little bit of a task to do all that stuff. But the whole purpose of all that stuff was to specifically get this right here. Notice in this step, I took x and y and I swapped them. Y became x, x became y. F of x is y. So if I swapped x and y, now x should have this relationship, greater than or equal to 0, in the inverse function. So greater than or equal to 0, and again, it came from right there. Whatever this says in the range, this is y, you change it to x to make the domain. So this is the answers. That's the inverse function. It is a function, so written inverse function notation, and the domain is that which came from the range. The f of x is changed to x's basically, and range changes to domain. F of x changes to f inverse of x. All right. 4 points, 2 points when it comes to grading. You get 2 points for getting the correct inverse. You get another 2 points for making the correct decision, whether it's f inverse or y equals, and then another 2 points for the correct domain. Okay, 10, 11, and 12 all use these two functions, and they're basically going back to problem number 6. It's composition of functions. So f of g of x is this expression. So f of g of x means f of that expression. So change g of x to that expression. F of that expression means 3 times something minus 1. The something, which is x, is changing into that stuff there. So I'm going to put x plus 1 over 3 in the parentheses. And then this 3 cancels that 3. Multiplication, whole number times a division. Multiplying and dividing by the same number cancels. So x plus 1 minus 1. And then you combine like terms. 1 minus 1 cancels, leaving x. So f of g of x is equal to x. Okay. Then we move on to g of f of x. G of f of x, and f of x is equal to that expression. So g of f of x means g of 3x minus 1. G of 3x minus 1 means we come to function g and we change this x into 3x minus 1. So g of 3x minus 1 looks like this. There's a plus 1 and a 3, and x goes right here, but instead of x, we're putting 3x minus 1. Okay, I want to simplify the top as much as possible before I deal with the division. So minus 1 and plus 1 cancel, leaving me with 3x over 3. And then 3 divided by 3 makes 1, so we get 1x, also known as x. So g of f of x equals x. Now, number 12 asks, based on your answer for problems 10 and 11, are f of x and g of x inverses one another? And the theorem in the book states if f of g of x and g of f of x both equal x, then you're looking at inverse functions. So f of g of x equals x, g of f of x equals x, so yes is the answer to problem 12. If either this one or that one came out to anything but x, you'd say no to that. So if this was x plus 5 and that was x, say no. If this is 3x plus 17 and that's 7x minus 5, say no. If they both say x plus 7, say no. Because again, they have to be x exactly or else they're not functions. So x, yes. Anything else, no for number 12. 6 points per problem, 72-point quiz. Prepare well for it. Hope this helps you.